Alright, you guys, so today we're going to do the 3-4 notes. You should have your note packet, your textbook, and it should be open to page 180. And then you should also have the 3-4 homework to look over when we're done taking the notes. So we're talking about direct variation, which is just another kind of line that we're going to see. It's still linear, and it's pretty easy. In the last couple of sections we've talked about standard form, we've talked about how to graph things using intercepts, we've talked about how to find slope using 2 points, how to find missing points if you have the slope, those kinds of things. This is very similar. So on page 180 of your textbook, you're going to see the definition for a direct variation. A direct variation is described by an equation of the form y equals kx, where k does not equal 0. So we're just going to put that down. An equation of the form y equals kx, where k cannot equal 0. Now, you've seen something like this. K is just our constant, and constant means it never changes in math. X and Y are just X and Y from our graph. X is the X-axis and Y is our Y-axis value. So when we talk about what this equation represents, we know that it is a line that has a constant rate of change. And in the last section we talked about rate of change is the same thing as slope when we're talking about graphs. So you're going to hear me call it rate of change, constant of variation, slope. They're all the same thing. So constant of variation or constant of proportionality is just our rate of change or slope. And for y equals kx, k is that rate of change or slope. So we usually call slope m, and so k and m are interchangeable. We're going to stick with the letter k because we're not talking about the different slope-intercept form, which is where we start seeing m for slope. We're talking about direct variation, so we're going to only use k for today. In a graph, we call the constant of variation the slope. We can underline those. If we graph the equation k or y equals kx, we know that it will always pass through the origin because 0 equals k of 0. And what that means is I can take y equals kx, I'm going to change this out to make it look like a function. And we know that y and f of x are the same. So I'm going to say this is the same thing as f of x equals k times x. Now, if I say I want to know what happens at f of 0, because remember, f of 0 is the same as when y equals 0, which is where it crosses the x-axis, equals k times 0. And anything times 0 is just 0. So I get the ordered pair 0, 0, x, y. 0, 0, which is the origin. So no matter what kind of direct variation problem you're going to see, it will always pass through the origin. If it doesn't, you might have made a mistake, or it might not be a direct variation question. Therefore, the x-intercept and the y-intercept are at 0, 0, or the origin. Now, think back to, I think it was the 3-1 homework where you had a problem where it passed through the origin. I told you to solve it using the intercepts, and it only had one intercept because the x-intercept and the y-intercept were both at the origin and were the same. So we couldn't graph that line because we only had 1 point. We're going to look today to see how we solve questions like that. Turn the page. The first thing it tells me to do is graph y equals negative 6x. We can do that. This is direct variation because I have my y equals kx. Y and x are the same. K is negative 6. Remember that k is your constant of variation or your slope. So I'm going to start making a table. I know that I'm going to have x values and I'm going to have y values to make my ordered pairs. I'm going to choose 3 values for x. I know automatically it's going to cross through the origin. I know that because it's a direct variation problem. Now I'm going to choose 1 point to the left of the origin and 1 point to the right of the origin. If I go to the left, I get -1, and if I go to the right, I get +1. So f of x equals -6x. I just took the y equals -6x and replaced y with f of x. I'm going to say f of -1 equals -6 times -1. F of -1 equals +6. -6 times -1 is +6. So my first ordered pair is -1, 6. The second one we know is the origin. We don't need to plug that in. We already know that that happens. Now at f of +1, I get -6 times +1, which is just -6. So I have my third and final ordered pair. Now I can start graphing. I'm going to take my ruler. You should have one of those. If you don't, pause and go get one. And I'm going to draw in my axes first. I'm going to draw them just down the middle. Same for the x-axis. I'm going to draw it right down the middle. Don't forget to label your origin. Alright, so the first ordered pair that I have is at -1, +6. So left 1, up 6. The next one I have is 0, 0, or the origin. The last one I have is 1, -6. So I go right 1, down 6. Okay, then go ahead and draw in a line from those 3 points. Remember that it needs to pass all the way through the points, and it needs to have arrows at each of its ends because that means that the line keeps going beyond our graph. Don't forget to label your points. Okay, so we have graphed y equals -6x. It's of the form y equals kx, and it passes through the origin. So this is a direct variation problem. So direct variation graphs have a couple characteristics. They are of the form y equals kx, where k cannot equal 0. If k equals 0, you get y equals 0, and that's actually an axis, not a line that we're worried about today. The graph of y equals kx always passes through the origin, or 0, 0, and the slope is either positive or negative. Slope cannot be 0 because if it's 0, we get a vertical line, and that's not something we're dealing with today. So it can be positive, and that means k is bigger than 0, or it can be negative, and that means k is smaller than 0. We're on page 2 now. So if you remember the relationship between these, remember it was y equals kx. We can say that in sentence form, and what we would say is if the relationship between the values of y and x can be described by a direct variation equation, y equals kx, that's what we've been talking about, we say it like this: y varies directly as x. And so I would start by saying the variable that appears first, I say y varies, so I'm going to say equals, directly means times, and I'm going to say k is my constant, times x. So let's see, if we have, suppose y varies directly as x. So we're going to say y equals kx. And they tell me y equals 72 when x equals 8. So I'm going to say 72 equals k times 8. Now, what they want you to do here, and I should have written this in, you can go ahead and write this in, find the constant of variation, which we know is k. I have a multiplication equation here. You guys know how to solve this. The first thing I'm going to do is divide each side by 8. 72 divided by 8 gives me 9. These 8's cancel. K equals 9. I can rewrite my direct variation equation now that I know that my constant is 9. Now, x and y can change. They're variables. They will change. That's what they're supposed to do. But K is a constant. It should never change. Now that we have found K for this specific equation, we can set up the equation that can change for x and y. We can say y equals kx, and I know that my k equals 9, so the direct variation equation for this problem is y equals 9x. That's a function. That's an equation. We know how to deal with that. Now it says, use the direct variation above to find x when y equals 63. I'm going to bring this down. Y equals 9x, and it says when y equals 63, what does x equal? Plug that in. 63 equals 9x. Again, I have a multiplication equation. I know how to solve that. I'm going to divide by 9 on both sides. What do you get? 7. These sides cancel. That's your answer. All right, one last page. Turn to the last page of your notes. You also need to have your books open to page 182. We're going to do real world example number 4. So we've been talking about distance and time and rate a lot this year, and this is just another example of when you would use it. It's one of the most common variation problems you'll ever see. It's one that you'll use almost any day that you're driving if you're wondering how long it's going to take you to get somewhere, or if you travel at a certain speed for a certain amount of time, how far will you go? That's basically what this is. It's also one of the most basic ones that you will see. So we know that the distance that you travel equals the speed that you're going times the amount of time that you're traveling at that speed. D equals RT. That looks really similar to Y equals KX. D is what stands for Y, T is X, and K and R are interchangeable. They are our constants. So I'm going to put that in there. I'm going to put Y equals D, or distance, K equals R, or rate or speed, and T is X, or time. Okay? So if I were to say that in sentence form, I would say distance varies directly as rate and time. Okay? Or distance varies directly as time. Okay? I already know that there's going to be a rate because I'm not going anywhere unless I have a certain speed. Okay? So take a look at the real world example. It gives us the problem. The distance a jet travels directly as the number of hours it flies. Oh, sorry, I read that incorrectly. The distance a jet travels varies directly as the number of hours it flies. A jet travels 3,420 miles in 6 hours. So we know that it travels this, we use this equation. We use D equals RT. Now it says it travels 3,420 miles. That's distance. And in 6 hours, that's our time. Let's find constant of variation, or we call it K in the typical question. This time we're going to use R because that's what we're using. So I'm going to say 3,420 equals R times 6. Now to solve, I divide by 6 on both sides. 3,420 divided by 6 gives me 570 equals R. These cancel. So now I know that I'm traveling at a rate of 570 miles per hour. I know that because I went 3,420 miles in 6 hours, miles per hour. Okay, so now I can set up my equation. I know that distance equals 570 times time. So sure, it traveled 3,420 miles in 6 hours, but maybe he's not done traveling. He wants to keep going. So we need to be able to find out if I travel this much longer, how far will I go, or if I want to travel a certain distance, how long will it take me? in the book, it tells us to estimate how many hours it will take for an airliner to fly 6,500 miles for part C. So I'm going to take this equation. I know that my new distance is 6,500. I'm going to plug that in. Equals 570 t. I'm looking for the amount of time. So I'm going to divide by 570, and I get approximately 11.4. I'm going to round. So after about 11 and a half hours, I will have traveled that 6,500 miles. All right, that's it. You have the notes now. You can rewatch the video if you need to. You should send me an email letting me know how this set of notes went. This is new stuff. You've never seen this before, so it might be a little bit difficult. You need to go through the notes and try to do your homework. Do as many as you can so that when you come to class tomorrow, you can ask the real questions that you have. You need to do the skills practice page and the word problems. Good luck.